Hello, Algebra 2 students. I wanted to go over a couple of examples of how to use trigonometric identities to help you simplify some of these expressions and give you one example of verifying the identity. So first, we'll start with this question here from your student journal. We've got 2 secant squared of x minus 2 tangent squared of x over tangent of negative x times the cosine of negative x. And anytime I see secant squareds and tangent squareds, I'm going to think to myself, there's got to be a Pythagorean identity that relates these things. So I went back to the previous page, looked up the Pythagorean identities, and found this one. 1 plus tangent squared of x equals secant squared of x. Now, this is not quite like this, but almost, right? Can I subtract a tangent squared from both sides? And I get 1 equals secant squared of x minus tangent squared of x. Okay, except we're missing a 2. So I'm going to factor out the 2 here. So make it 2 times the quantity secant squared of x minus the tangent squared of x. And now the top part has a piece that looks like this secant squared of x minus tangent squared of x. And in for that spot, I can ultimately substitute a 1. And 2 times 1 is just 2, right? But we have to deal with this denominator. Tangent of negative x times cosine of negative x. Well, that is the same as negative tangent of x, right, times the cosine of x. And we're using those identities on the previous page. And let's see, also tangent of x is equal to sine of x over cosine of x. So negative tangent becomes negative sine over cosine times the cosine of x. So those cosines cancel. You're left with negative 2 over the sine of x. And when you have a sine of x in the denominator, that is the same as a cosecant of x. So this simplifies to negative 2 cosecant of x. Boom. And now I want to look at one of these verify the identity problems. These problems are tricky because there's more than one way to do them. There is more than one way to do these problems. And so you can have multiple correct ways. There's also multiple wrong ways to do these problems. But let's take a look. When I see 1 minus cosine squared of theta over secant squared of theta, and then minus sine squared of theta equals negative sine to the 4th power of theta. Normally, when I do these types of problems, I want to work with one side and simplify it until I can get it to look like the other side. But sometimes you have to work on both sides. Sometimes that's what you have to do until they equal each other. So I started by breaking this into 2 separate fractions. I made it 1 over secant squared of theta minus cosine squared of theta over secant squared of theta minus sine squared of theta. Okay, well then if I have a 1 over secant squared of theta, that's the same as cosine squared of theta, right? And this could be written as cosine to the 4th power of theta because secant squared is just 1 over the cosine squared minus the sine squared of theta. Okay, I still need to get this to look like negative sine to the 4th power. So let's deal with these cosines here. Maybe I can factor out a cosine squared. So if I factor out a cosine squared of theta, then I would have 1 minus cosine squared of theta. And then we would, let's see, what can we do next? 1 minus cosine squared of theta. You get sine squared of theta plus cosine squared of theta equals 1. if I can subtract cosine squared from both sides, that is 1 minus cosine squared of theta is equal to sine squared of theta. So I can substitute that in here, right? Cosine squared of theta times sine squared of theta minus sine squared of theta. Well, now I'm going to factor out a cosine squared of theta. Nope, sine squared of theta. Factor that out. So then I'm left with sine squared of theta is equal to sine squared times cosine squared minus 1. There we go. And the cosine squared minus 1 is the same as negative sine squared of theta. And so if you have a sine squared times a negative sine squared of theta, that is equal to negative sine to the 4th power of theta. And boom, we have done the problem. These types can be kind of confusing, and like I said, there's more than one way to do this problem. I hope that you are all well, and we will see you next time.